Planet 9. Yes, let's actually get to the point. Not to be confused with Planet X, proposed in 1906 by Percival Lowell. This article is about the hypothetical planet first suggested in 2014 for the dwarf planet previously classified as the solar system's ninth planet, Pluto. For other uses, ninth planet to blah, blah, blah. All right, so Planet 9 is a hypothetical ninth planet in the outer region of the solar system. Its gravitational effects could explain the peculiar clustering of orbits for a group of extreme trans Neptunian objects, ETNOs, bodies beyond Neptune that orbit the sun at distances averaging more than 250 times that of Earth, aka 250 astronomical units. These trans Neptunian objects tend to make their closest approaches to the sun in one sector, and their orbits are similarly tilted. These alignments suggest that an undiscovered planet may be shepherding the orbits of the most distant known solar system objects, aka there seems to be some gravitational effect that we cannot account for. So, since previously unabsorbed gravitational effects, it's like, maybe there's another planet out there. And it seemed to work. That's, again, kind of how we got Uranus, Neptune, bada boom, bada bing, let's try it again. But ultimately with the redefinition of planet, because we want to update our definition so we can actually be accurate, because it's not like we're just going to scream out there into whatever's totally not the ether, to just scream enough that people will be like, well, that's obviously right. Why? Because this person just yelled a bunch and made a big stink about it. Because obviously rewarding bad behavior is the best way to stop it. All right. Let's continue. Nonetheless, some astronomers question this conclusion and instead assert that the clustering of trans-Neptunian objects is due to observational biases stemming from the difficulty of discovering and tracking these objects during much of the year. AKA, it's really hard to get good, clear pictures of stuff that's really far away, and especially if it's really chilly. Now, if it was like thousands of degrees Kelvin, if it was like even like a white dwarf or something like that, it's like, all right, it's probably going to be pretty hot. Even if it's several thousand degrees Kelvin or something like that, it's like, even if it was small, it would be hot, so we would be able to pick up those different wavelengths. Right now, it's like, all right, if it's really far away, and things like Bill was pointing out, if they seem to be mostly just covered in ice, that's pretty chilly. So it's very hard to be able to pick up, and it literally took like one of the dark energy surveys to help like locate this thing. That's pretty crazy because, again, they were pouring through the archival data, because if you see something, again, it's, I don't know, maybe it's just a stray cosmic ray. Who knows? Maybe it's a thing of dust. Like, before the lens, it could be that. But you want to have multiple observations and actually have confirmation because, that's science. Because, I mean, what was it? Back in the day, it's like magnetic monopoles, because charge typically, charge comes off very much, like a proton or electron. It's emitting charge, and it kind of seems to be doing its thing, but magnetism always works in like a dual way, aka you cut a magnet, it's like, all right, it still has poles. It's not like, oh, well, this is just the positive side and this is just the negative side. For some reason, every time you break a magnet, it's going to have like a north and a south, at least according to our general description as far as its impact there. But long story short, magnetic monopoles, there was a detection, like on it was on Valentine's Day, like a long time ago. So a person that saw this, the thing is, apparently we never really saw it again. Now maybe there had been, some people may have claimed that, okay, maybe they saw it, but it's one of those results that if we couldn't replicate it, it's like, maybe it was just kind of a fluke. So hence why we want to have as much good quality data as possible that we can go through and actually try to validate this. All right. So let's continue with Planet 9, not to be confused with Planet X, which is another thing, and or the planet that was eaten by a black hole in some of the Godzilla movies. Oh no, the zillions are coming! The zillions are coming! Oh, geez. Satire. All right. Based on earlier considerations, this hypothetical hypothetical super Earth-sized planet would have had a predictive mass of 5 to 10 times that of Earth and an elongated orbit of around 400 to 800 astronomical units. Okay, so that kind of lines up with at least the orbit of our other observational detection there. The orbit estimation was refined in 2021, resulting in a somewhat smaller semi-major axis of about 380 astronomical units. This was shortly thereafter updated to 460. All right, so we're jumping all around there, and then eventually in 2025, aka this year, it was about 290 astronomical units, plus or minus 30. So yeah, about the lower end of the range of Pluto there. All right, so astronomers Konstantin Batygin and Michael Brown have suggested that Planet 9 may be the core of a giant planet that was ejected from its original orbit by Jupiter during the genesis of the solar system. Others suggest the planet was captured from another star once it was a rogue planet, or that it formed in a distant orbit was pulled into an eccentric orbit by a passing star. The sky surveys such as the Wide Field Infrared Survey Explorer, WISE, that's a cool name. All right. And band stars did not detect Planet 9. They have not ruled out the existence of a Neptune diameter object in the outer solar system. Its ability, well, maybe it is now. What is it? All right, so it's purely conjectural. Let's see, have they updated this article yet? As we're getting to the end here. Let's see, citation. Okay, maybe people will wait until there's more reporting. All right, people are still conjecturing. And again, we conjecture because, well, it's fun. And that's why, if you're not wrong, then, well, how do you start doing science? Because we want to cast aside our misconceptions. All right, so is that's solar or no, that's Earth mass. All right, because we have there. All right. Where's the observation? Continue. Evidence. All right, so trans Neptunian objects. All right, we've discovered a bunch of them. How long is this? Oh, wow, there's so much stuff on Planet 9. All right, so here's how we quickly find something. All right, so OF201, literally go in here, file, search. All right. So the only reference in the entire Planet 9 article is right here. So they have a link here. Let's take a look. All right. So it's an extreme trans Neptunian object and dwarf planet candidate estimated to be about 550 kilometers in diameter. All right. So it's got an absolute magnitude of 3 or 4. It may be the brightest. It does not have a directly estimated size. What? Okay. Because that's interesting, because I think that's, what is that, like the solar albedo or something? Oh, that must mean it's very shiny. So when they say the brightest known object in the solar system, base reaction, you're like, the sun, dang it! It's obviously the sun. Yes, that is the actual brightest. But as far as at least shiny reflectivity, incorporating its distance, if it's really freaking far away and it's only slightly less bright than Pluto and it's much further away, there might be something there. Or at least that's my initial logic there. All right, so its current distance is about twice the distance of Pluto. The May 2025 announcement of 2017 OF may end up disproving the existence of Planet 9 and possibly planets beyond Neptune in general. The orientation of the orbits of extreme trans Neptunian objects tend to cluster. This clustering led to the hypothesis that a possible distant planet has influenced those orbits. However, the orbit of 2017 OF is one of the few, such as some of these other guys here, that is anti-aligned to the calculated orbit of Planet 9. Modeling suggests the hypothetical planet would have ejected 2017 OF from its current orbit over timescales of less than 100 million years, although it could be a temporary orbit. Okay, so that's ultimately one of the biggest, quote-unquote, nails in the coffin, so to speak, of the Planet 9 hypothesis is if you actually did have a Planet 9 of several Earth magnitudes, and if it was going around the same place, it likely would have kicked this thing out of the orbit a long, long time ago. Hence, one might intuit maybe there isn't a Planet 9. Now, that's not to say that there isn't other stuff out there that we don't know, because, well, let's face it, most of that stuff that far away, it's incredibly hard to see, so how can we tell what's actually going on? It literally took, what, like 7 years of data combing through and then matching and probably using different algorithms and probably some AI assistance at this point now to help actually point out a pattern, I thought I saw a pattern, and then be able to trace out and estimate its orbit. All right. So it orbits far beyond Neptune at an average distance of, it's about 20 times the standard far distance of Pluto, which was about 50 AU. Taking 25,000 years to go around. Okay, so most of the stuff is from the paper. Okay, so let's go physical character. This is one of the reasons why I do like Wikipedia, because it's laid out in a very simple fashion. Okay, so the diameter is unknown but estimated, so as we saw, about 500 to 800 or so kilometers there, placing within the range of a possible dwarf planet. And then Pluto, for reference, is about 2,300 kilometers in diameter. So that means if you were to have a tape measure going straight through Pluto, it would be about 2,300 kilometers, or that's probably around like 1,500 or so miles. So this is a lot less. Yeah. As we can see, even Eris was slightly smaller. That's another trans-Neptunian object, but Eris appears to have slightly more mass than Pluto itself. So it's like, unless you're going to make all those planets and you're going to redefine the definition of planet again, they're dwarf planets.